Right. Our next topic is unit step function. Unit step function is a very important function in mathematics and physics and engineering as well. The definition of the unit step function is, let's copy it from here. There are many phenomena in our daily life. For example, turning off a switch. It has only two states, on or off. For example, yes or no. For example, questions like true or false. So they have only two states, two answers. They can achieve only two values, 0 or 1, just like binary digits. So this function has only two values, 0 or 1. For certain time, it remains 0. So between 0 and a, the value of the function is 0. Let's say a is time. It's the time axis. Let's say t is the time axis and a is some time. So up to certain time, the answer is 0. And after that time, the answer is 1. And it remains 1 forever. So it has only two values. Clearly, it's not a continuous function. It's a discontinuous function. And it is a very important function. It can help us understand mathematically the phenomena which has only two states. Now, because we are studying Laplace transform, so we are going to study the Laplace transform of this function. Laplace transform of u of t minus a equals e raised power minus as over s. Now, one thing is very notable. Before all the formulas for Laplace transform, they do not have, this is the list of all formulas, starting with Laplace of 1 over s, Laplace of t power n, it has n factorial over Sn plus 1, and then s minus a, and so on. None of these formulas has e on the right hand side in the answer. You see, there is one formula which has e on the left hand side. We take Laplace of e power at and we get 1 over s minus a. But now in case of unit step, u of t minus a is the function and answer is e power minus as over s. For example, let's say if a is 3 in case, then this would be minus 3s over s. So far it's very simple. So Laplace of the unit step is e power minus as over s. But the more important situation is when unit step is multiplied with another function. For example, Laplace of f of t multiplied with ut minus a. Okay. For example, Laplace of t square, or let's take an easy one, t and something Laplace of t ut minus a. This thing is called second translation theorem. This formula is called second translation or shift theorem. I'll copy the formula from the list so that it is easier to remember. I'll write the example again. So let me copy the formula from the formula list so that it is easier to. So here is the formula number 29. That's second translation theorem. I will add one more step in between, should have written in the formula, but I'll write it again. So what we do is, as you can see, there are two things in the left hand side. There is a function, just like we did our first translation theorem, there is a function and there is ut minus a. Okay, so this one ut minus a tells me that I have to use second translation theorem. Ut minus a contributes e power minus as, and we take Laplace of f of t and then shift it by a plus a. So actually we are going to write it like this. Let's rewrite the formula slightly differently. So Laplace of f of t, t goes to t plus a. I think we'll use it that's better. Let's not use the shift here. Right. So once again the story has come down to shift. Okay. Let's take a very simple example, the one I wrote already. Laplace of t times ut minus 2. Now you can see this one, t is our f of t, and here we are going to get a from here. Okay, ut minus a, ut minus 2, so our a is 2. Copying from the formula e power minus as, a is 2, so that becomes minus 2s. Laplace of f of t plus a, what is a? A is 2, so t plus 2. Right. Now let's look at the situation. F of t is t. If f of t is t, what would be f of t plus 2? So we put t plus 2 in place of t. That will give t plus 2. Simply because there is a t and then we get t plus 2. Okay. It means here f of t plus 2, we will put t plus 2 because our function is t only. This becomes e power minus 2s Laplace of t plus 2, which is e power minus 2s. We have to separate the Laplace of t and Laplace of 2 because there is an addition between, and Laplace can be separated over addition, and that gives e raised to minus 2s. We can keep e raised to minus 2s outside. It is multiplied with both 1 over s square plus not 1 over 2 over s. So our answer is 1 over s square plus 2 over s e raised to minus 2s. No need to take this LCM, just we can leave it here. So let's have a look at it again. Whenever we have a unit step function multiplied with another function, we take Laplace of the function, but first we have to shift it by a. So if f of t is our this function, we write f of t plus a. Okay. Where do we get a? Where do we get a? A is coming from here, t minus a. So that's where the a is coming. Here with the same minus sign, but here it is plus sign. So please note that minus 2 minus 2s e power minus 2s, but here it is plus 2. So that's a very important difference to note. Let's see, just in case, for example, if f of t was t cube, what would be f of t plus 3? Can you think of? Pause the video and think about it. If f of t is t cube, what would be f of t plus 3? Would it be t plus 3 cube? Yeah, that's correct. Let's say if f of t, again, as you can see, it's almost the same kind of shift which we have done in the previous two topics. Okay, we are replacing t by something shifted t plus 3. Okay? Let's say if we have sine of 3t, what would be f of t plus pi? Will it be sine of 3t plus pi? Pause the video, think about it. So first answer, Second possibility, sine of 3t plus pi, like this. Which one would you choose? Correct answer is this one is the correct answer. This is the wrong answer. Because we are shifting t. Okay? So we are going to observe this thing as sine of 3 and a t. So we are going to replace this t here, and this will take t plus pi. So 3t plus pi. T is replaced by t plus pi, and 3 is outside the bracket now. Okay, and here is sine. So like this. So that's why it will look like sine of 3 times t plus pi in the bracket. And if I expand, it would look, if I want to do one more step, 3t plus 3 pi, not 3t plus pi. That is wrong. 3t plus 3 pi. 3 will multiply both. This is the correct answer. Alright, let's continue our practice into a Laplace transform. What if we have, it is question number 40, Laplace of 3t plus 1 ut minus 1. Okay, so our function is this is our function f of t, and from here we know that our a is, from here, let's try it again. From here we know that a is 1. Okay, right. Formula says e power minus as, so 1s, Laplace of f of t plus 1. Okay, t plus a. Remember the difference between minus as, so this minus a, minus s, and plus a here. Okay, this time the shift is plus a here. Okay, this one is right. Now we have to figure out our f of t is 3t plus 1, and we have to make f of t plus 1. So 3, okay, first of all, I'll write it again. So f of t, 3 multiplied t plus 1. Whatever we put here will replace here, and we are going to put f of t plus 1. So that means it becomes, we want to replace this with t plus 1. So t plus 1 will become here and plus 1. That gives, now we open the bracket, it gives 3t plus 3 plus 1, or in other words 3t plus 4. So our f of t plus 1 is 3t plus 4. That's what we are going to write. E raised to minus s, that is from the unit step, Laplace of 3t plus 4. Please note that f of t plus 1 is not equal to 3t plus 1 plus 1. T plus 1 does not mean just add 1 into the function. No. That does not mean. F of t plus 1 does not mean just add 1 into the function. No. Replace t with t plus 1. Okay. So when we replace t with t plus 1, that is a different thing. That is how it works. T is gone, t plus 1 replaced, and 3 multiplies again, and that gives 3t plus 4. Now we write e equals e raised to minus s, Laplace of 3t separate plus Laplace of 4 separate. We can put a big bracket here. Just e raised to minus s is multiplied with both, and this gives 3 over s here plus 4 over s. We can leave it here. That's the answer. All right, it will take you to a quiz now. Please do the quiz and come back and okay, let's continue our unit step, Laplace with unit step. Our next question is question number 41. Laplace of cos of 2t ut minus pi. So let's visit our formula again. Our formula says, so our pi is a in our this case, and f of t is cos of 2t. So this is f of t, and from here we see that a equals pi. That tells us that we are going to do e raised power minus pi s, same sign, minus pi and minus s, Laplace of f of t plus a. So t plus a would be t plus pi. Now we have to find f of t plus a. So f of t is cos 2t. Okay? So f of t plus pi would be cos of 2 times t plus pi. Remember the previous example. 3 and plus 1, 3 multiplies with t plus 1 in the bracket. Okay. Similarly, 2 multiplies with t plus pi in the bracket. So this becomes cos of 2t plus 2 pi. Again, remember that cos of 2 times t, okay, that is where we replace our new variable, which is t plus 1. Okay, that is where we replace our new variable t plus 1 and bracket. So we replace t with t plus 1. Okay, so 2 is outside, then 2 can multiply inside and become cos of 2t plus 2 pi. So our next step would be minus pi s Laplace of cos of 2t plus 2 pi. Now the next problem, a little bit of problem, is our formula for cos. Where is our formula for cos? Here is the formula for cos, this one. It is cos of kt, not cos of kt plus something. We have a situation of cos of 2t plus something. Okay? So our formula will not help directly. We have to expand this using trigonometric identities. 2t plus 2 pi equals cos 2t cos 2 pi. Let's make some space so that we can fit it in one line, plus sine 2t. Still fit, so plus sine 2t sine 2 pi. We have used the formula cos of a plus b equals cos a cos b. This should be minus sign, if I remember correctly. There's a mistake. This should be minus sine a sine b. Okay. Now we can write our answer again. So this is equal to e raised power minus pi s Laplace of cos 2t cos 2 pi minus sine 2t sine 2 pi. Well, you can use your calculator and you can find out that cos 2 pi is plus 1 and sine 2 pi is 0. So this means our next step, minus pi s Laplace of cos of 2t, which means now we can use our formula because it's simply cos of 2t, which can be calculated using cos of kt. So k equals to s over s square plus 4, and that is our answer. So the whole story depends on calculating f of t plus pi correctly. Okay, it's the same shift we are using in the last two lectures. Shift, if you understand the shift properly, you can solve all these questions very easily. Let's do one last question on this shift. It is question number 42. Laplace of sine of t into ut minus pi by 2. Alright, pause the video. It's your turn. It's almost exactly the same as above. You might need this one formula, which I'll write it for you here. Sine of a plus b, which is equal to sine a cos b plus cos a sine b. I'd like you to pause the video and give it a try. Alright, I hope you have done it already. Our function is here, so minus pi by 2s, okay, because a is pi by 2, and into Laplace of function t plus a, where a is pi by 2. Okay, this is our function. This is our function, and a is pi by 2. Right. So how do we write f of t plus pi by 2? E raised power minus pi by 2s Laplace of sine of t plus pi by 2. Now we use this expansion here, and we can write minus pi by 2s Laplace of sine of t into cos of pi by 2 plus cos of t into sine of pi by 2. And now we can we know from our calculator that cos of pi by 2 is 0 and sine of pi by 2 is 1. So our question becomes e raised power minus pi by 2s Laplace of, not cos of t, cos of t, because this term goes to 0, so no need to write this one, and e raised power minus pi by 2s. What is Laplace of cos of t? S over s square plus 1 square, which is 1. So we stop here.